In this lesson, you will learn how to use the square root method to solve quadratic equations. Remember that a quadratic equation is just an equation that's in the form of ax squared plus bx plus c. In other words, if it has an x squared, then it's a quadratic equation. So let's go ahead and get started. With the square root method, it only works with certain quadratic equations. It works if the middle term bx is missing. So if there's no x term, it has to have an x squared because it's a quadratic, but it does not need to have the bx term. That would be like number 1, 2, and 3. The other way that it works really well is if you have like number 4 here, you have parentheses and then you have a squared. It's gonna work for number 4, number 5, and number 6. Let me go ahead and get started with the example so that you can understand it. For number 1, okay, so the goal of all these is to get the x squared by itself. Once you get the x squared by itself, you can get the square root of both sides and then you solve. So get the x squared by itself, square root, and solve. That's what we're gonna be doing. So for number 1, the x squared is already by itself, so I can get the square root of this side and the square root of that side. I'm getting the square root because the square root is the opposite of a squared, so they essentially cancel out, and all I have here is x. What is the square root of 64? You may know that to be 8, but when you're solving, it's going to be plus or minus 8, or in other words, it's going to be a positive 8 and a negative 8, because 8 times 8 is 64, and also negative 8 times negative 8 is 64. So since I have the x by itself, I am done. My answer for number 1 will be 8 and negative 8. For number 2, the squared, x squared, is not by itself. So first I need to move this 4 to the other side. Remember, the opposite of addition is subtraction. So subtract 4, that's going to cancel. So now I have x squared equals 0 minus 4 is negative 4. Now the x squared is by itself, I can go ahead and get the square root, So I finally have my x. What is the square root of negative 4? That is actually not a real number. So it's what we call an imaginary number, which we don't cover in this course, but it is covered in my master course. So when you run into where you're getting the square root of a negative, you are going to say it's an empty set or no solution, because there's no square root of negative 4 that is real. All right, moving on to number 3. Here I'm going to add 10 to get that x squared by itself. So I have 2x squared. The 10's cancel, so here I have equals 10. Divide by 2. So I have x squared equals 5. Finally, I'm ready to get the square root. Square root of 5 is simplified. So for number 2, that's as far as you can go. I'm going to get x equals plus or minus square root of 5. This will be my answer. I tried to squeeze in as many examples as I can on the board so that you can see different types of scenarios of how to work this out. So just bear with me on the space. Number 4, I have parentheses, x minus 5 squared equals 49. So when you have parentheses, you just want to make sure the part that is squared, which is what's in your parentheses, is isolated all by itself, which it is for number 4. So now I need to get rid of this squared so that I can get this x out. So I'm going to get the square root of this side, and I'm going to get the square root of that side. That's going to cancel. Here I have x minus 5 equals square root of 49. Remember to always do your plus or minus, because when you're solving, it will apply to positive and negative. If I would have been done with just x here, I would have said the answer is plus or minus 7, but I need to bring the negative 5 to the other side. I recommend you split up this into 2 equations. So you have x minus 5 equals your positive 7. X minus 5 equals negative 7. So I just split up my plus or minus 7 so that it's easier to solve. So now opposite of subtraction is addition, so add 5 to both sides. I get x equals 12. Add 5 to the other equation, and you get x equals negative 2. So this is an answer, and that's an answer. Okay, number 5. So here's my squared. The negative 32 is not part of it, so it has to go to the other side. So add 32 to both sides. So I have 3y minus 7 squared equals 32. Now I'm ready to get my square root on this side, get my square root on that side. That's going to cancel. So I have, I guess I'll write that here, 3y minus 7 equals plus or minus the square root of 32. The square root of 32 is actually not a perfect square, but you need to simplify this. I don't know if you remember how to do that, but I'll go ahead and do it. How I do it is, I think it's easiest to just do a tree. What times what is 32? I would say 16 times 2. You could say 8 times 4. It really doesn't matter. Then here I have 16. That's 8 times 2. You have 2 times 4 and 2 times 2. When you're doing a square root simplification, any two numbers that are the same go in a circle. I could pick any two numbers. So I see 2 2s, that's one set. I see another set. The sets come outside. So I have a set of 2 and a set of 2. So that would be 2 times 2, which is 4. On the inside is whatever's left. If you have more than one number that's left, you multiply them. This is the only thing I see left, so that's a 2. So square root of 32 simplifies the same thing as saying 4 square root of 2. So I'm going to come here and say that. Next, I need to continue solving for y. So I'm going to add 7. I'm not going to split this up. You can, but I'm not going to do that just because I already see you can't really add this to the 7. We're just simplifying as much as we can. You do want to put the 7 in front of the plus or minus though. So here I have 3y equals 7 plus or minus 4 square root of 2. Divide by 3, divide by 3. Here I have y equals 7 plus or minus 4 square root of 2 over 3. If you could have simplified this, you would need to do that. So I think I'm going to show you an example of what I mean at the end. Let me go ahead and work on number 6, but I'm going to show you how you may turn into a situation where you can simplify this, but you can't simplify this one right now. So we're going to stop. Okay, number 6, this is already by itself. I thought it would be good to throw in a fraction in there because I know a lot of people don't like fractions. So go ahead and get the square root of this side, get the square root of this side. On that side, that will cancel. Here I have m plus 1/3 equals plus or minus square root of 1 over 9. The best way to do this is get the square root of the numerator, which is the top, and get the square root of the denominator. Square root of 1 is 1. Square root of 9 is 3. Now, because the squared part is gone, is when I'm going to split this up. So I have m plus 1/3 equals a positive 1/3. And then I have m plus 1/3 equals a negative 1/3. So subtract 1/3, subtract 1/3. So I have m equals 1/3 minus 1/3. I'm subtracting the same thing, so that's just 0. Here, I'm going to do the same thing, subtract 1/3, subtract 1/3. So I have m equals negative 1/3 minus 1/3. Remember, you just need your denominator to be the same, and then you can go ahead and combine the numerator. So since my denominator is the same, I don't even have to worry about that. So you do negative 1 minus 1, which is negative 2, and you keep your denominator the same. So the answer here would be negative 2/3 and also 0. So now come back to this one. I want to do an example of, say we've simplified an equation and then we get something like x equals 6 plus or minus 4 square root of 3 over 12. You can only simplify this if you have a common factor between the 6, the outside number, never the inside of the square root. Think of it like it's blocked in there, and the denominator. If there's a number you can divide by all of those, you want to go ahead and do that. So for this one, I know I can divide all of them by 2. So 6 divided by 2 is 3 plus or minus 4 divided by 2 is 2. Square root of 3 over 12 divided by 2 is 6. I know I cover this in completing the square and also in the quadratic formula video. So just watch on and you'll be able to understand this a little bit more. But I just thought it would be nice for me to touch on it. And that is how we solve quadratic equations using the square root method.